two groups. Lipids are the kind of fats, oils, okay, even waxes. That would be one kind of category of a lipid there. But they're also steroids. Fats, oils, and waxes are kind of all the same, but they just kind of have different melting points. A fat has a higher melting point than an oil has. Right? That's what makes the difference between those two. Oils and waxes are produced by plants mostly, although there are some animal oils like fish and things like that. Fats are mostly in animals. These are long polymers of hydrocarbons. They're these long chains. And they often group together into these things. I'll show you a picture of one here in a minute. Or form these things called fatty acids. I guess that's what it's called. And these fatty acids will join together to make something called triglycerides. So the way we store them and transport them are as triglycerides. The long polymers of hydrocarbon form these fatty acids. So all of these are fatty acids. I mean, just look at this. Long hydrocarbon chain, that's the fatty part of it. What makes it an acid? The hydroxyl group on, what's this group called here? That's a carbonyl. Carboxyl. So that's a carboxyl group. But you're right, it's the hydroxyl group that makes it an acid because it'll donate that hydrogen. Now this one we call saturated, and the reason it's saturated is because it has as much hydrogen on it as you could possibly put on it. So it is saturated with hydrogen. This one, on the other hand, is a mono unsaturated fatty acid because at one place right here, we replace that single bond with a double bond, and it's missing a couple hydrogens. So there's a single double bond which makes it mono unsaturated. This one would be polyunsaturated, right? Because look how it has even less. And what's interesting is that as you make things more unsaturated, the melting temperature goes down. So at certain temperatures, these are more likely to be solids, these are more likely to be liquids. And the viscosity goes less and less, meaning that they get less thick the more unsaturated they are. So you have heard probably that it's better for you to have one of these in your diet as opposed to the others. Which one's better?
Polyunsaturated.
Polyunsaturated because they're easier to transport around in your body. They're more, they're less viscous, they're more fluid, easier to transport. These tend to be solids at body temperature. Animal fats tend to be solids, which is what these are. Most animal fats are saturated. And you're aware of the fact that, and I won't get into the chemistry of this, but you can take something like this and turn it into something like this by adding hydrogen, right? We call it hydrogenation. And we do that to peanut oils, right? If you like Jiffy peanut butter, it's nice and creamy. Why is it nice and creamy? Because it's really lard. Now, you've taken something that was relatively healthy, like peanut oil like this, and you've turned it pretty much into pig fat by making it be something like this. So go ahead, you might as well have your lard and jelly sandwiches for lunch. It's really about the same thing. But you do know if you eat natural peanut butter that's nothing but peanuts, maybe some salt, it's always got a layer of oil on it, right? And that oil is because it's this. It's a liquid at room temp. The other thing the process of hydrogenation does is it creates what are called trans fatty acids, and it flip-flops the orientation of some of the hydrogens, which makes it more difficult for the body to deal with because we're not used to seeing those trans fatty acids in a natural situation. We'll chat more about that when we do some nutrition a little bit later. Okay. So these are the fatty acids. Now, these are used for long-term energy storage because these hydrocarbon bonds are very high in energy relative